Okay, now we are doing error and power. Okay, so what sort of errors we make? There are two kind of we make. One is type 1, one is type 2. Type 1 is we reject H0 when H0 is true. So that's alpha. Well, we also call alpha the significant level. And how much do you remember we're doing the confidence thing? So confidence is 1 minus alpha. So let me write this. Confidence equal to 1 minus alpha. And error is alpha. Okay, now let's go to type 2 error. So there's type 2 error, it's beta. And here, something called power is 1 minus beta. So just here, hear me out. So there are alpha and beta are the probability you're gonna make a mistake. Alpha is when H0 is true, we reject it. And beta is when H0 is false, we accept it. Actually, we never say we accept something, we just say we fail to reject. Okay, so alpha and beta are all probabilities of something bad. It's a mistake. So 1 minus alpha is confidence. That's a positive word. And 1 minus beta is power. That's another great word, right? Okay, this is how you remember it. So what's the now another thing I want to say is alpha plus beta is not anything. So alpha plus confidence is 1. Beta plus power is 1. Okay? But there are relationship between alpha and beta. We're going to explore that later. And there are two kind of errors you can make. So how are we going to handle the relationship between them? So normally we fix the probability of alpha at a certain level. We do 0.05. And then we minimize the probability of type 2 error, that's beta. So we fix alpha at 0.05 and then we minimize beta as much as we can. Why? Because normally the first kind of mistake is worse than the second kind of mistake. Okay? Okay, so definition in another form. So this one means H0 is true and we do not reject H0. That's yay, you did it right. And this is H0 is false and we fail to reject H0. That's a great part because that's the correct ones. And here there's two. This is alpha and beta. Okay? So why we are saying alpha, if you're making a mistake here, it's worse than making mistake here. So say I actually have a disease. And when I went to test, the test says I don't. So that's a really horrible thing, right? That's the first kind of mistake. I have breast cancer and I go to test and then the test didn't tell me I have breast cancer. That's a really, really horrible test. The mammogram or something like that's a really horrible test, right? So that Or what's the type 2 error in this situation is I'm not sick, I don't have breast cancer. But when I go to screening, they say, well, probably you have. So for me, the worst thing gonna happen to me is I go for a second test. And then the second test clears me out, right? So it's worse to make the first kind of mistake than the second one. If I'm sick, I want to be able to know that so I can have treatment. Yeah. So if I'm making the first kind of mistake, I'm sick, but I went to a screening and they didn't really pick me out. That'll be really horrible because I'm just gonna develop into a late phase cancer. And if the second kind of test, the second kind of error, I'm just gonna go through. I'm gonna probably pay a little bit more money to do a second test and then get myself cleared, right? So that's not really a bad outcome comparing the first one. Okay, now here, let's say where is alpha? So this two solid line, this one is one-sided and this one is two-sided. Alpha, let's say alpha is 0.05. So if it's one-sided, this part is gonna be alpha. If it's two-sided, this part plus this part is gonna be alpha. So this part is 0.025 and this one is 0.0252. 0.0252. Okay. Yes. So now we have already found where is the alpha. So where is the beta? Take a deep breath. We're gonna go through the next picture. Okay, here. Right. So now we still have the solid line. That's the H naught. And then from this alpha, we can calculate the critical value, right? We're using the inverse command. We have this critical value. And now this line is the H alternative. On this side of the H alternative, that's beta. And whatever under H alternative that's not beta is power. Okay? So that's why you cannot really add alpha and beta together because beta is under this pink one and alpha is under this black one. Okay? Awesome. So you've seen this one. What if this, this one, like H naught is on the left side of H alternative? What if it's like you flip it here? So this is H naught and you have alpha here. This is still one-sided, just like last one, okay? You have alpha here and this is your critical value. Now you have the critical value here. This is the real world. This is the dotted line. You have the critical value here, and on this part, it is beta. And whatever under this dotted line that's not beta is power. See this in this graph, power included alpha. And in this one, power included some part of alpha too, but yeah. Okay. How about when it is two-sided? Okay, let's go. Right, for this graph, because it's two-sided, so this right part is gonna be alpha over 2, and this right part is gonna be alpha over 2, right? Then you have two critical value. So in some of your homework, I said you need two critical value. Now you know why, right? Because that's a it's a two-sided test. Okay, so you have two critical value. So between these two critical value, that's beta. So you see this dotted line and this red one, this really skinny black one, and this red one. So this part is a beta. And where is 1 minus beta? Where is power? Okay, whatever under this one that's not beta is power. So power means this part and this part. So it's quite intuitive. You have the, if this is the dotted line and this part is beta, then you know there's line. So this and this together should be 1 minus beta. That's power, right? So that's why there is a little bit of purple and all this purple. Okay, so that is power. All right. Okay.